for you. I'm going to push my furnace to the absolute limit. Today I will try to melt some iron. These two weights will be my source of iron. Pure iron has a very high melting point of over 1500 degrees Celsius. I might be able to achieve this temperature, but I will probably need to use most of my propane bottle. Luckily there's a way around this problem. Our solution is called cast iron. Cast iron is the eutectic alloy of carbon and iron. It melts at around 1150 degrees Celsius, which is much more achievable. It's just a bit higher than the melting point of copper. To really cast the iron, I will bring my furnace up to around 1400 degrees Celsius. This is to make sure that the iron doesn't solidify immediately when it hits the mold. To melt the iron, I will need quite a lot of propane. Now I have two problems. First, it's quite cold outside, so the bottle is already cold. And second, when using a propane bottle, the bottle will cool down over time. This is due to the Joule-Thomson effect. A cold bottle gives off much less propane than a warm one. And to melt iron, I need a steady stream of gas. I'm solving both problems by preparing a small hot tub for my gas bottle. The water isn't too hot. It's maybe around 40 degrees. Before I'm starting the melt, a few words about safety. Molten iron is extremely hot. It's hotter than copper and almost 3 times the temperature of molten aluminium. Safety gear is absolutely necessary. I'm wearing welding gloves, a leather apron, a face shield, and I'm also wearing welding goggles. Molten iron is more than hot enough to give off harmful UV radiation. Also, it's impossible to see into the furnace without the welding goggles. The furnace hasn't been used lately, so it got a bit wet. The water is now escaping as steam. You may have noticed that the weights are a bit too large for my crucible, so I need to break them up. This is very easy to do with cast iron. Maybe some of you have already heard that you should never forge cast iron. In the following clip, I will show you the reason for that. Cast iron is very hard and brittle. The weights break with the first hammer blow. There are also cool sparks as a bonus. I'm loading the now smaller pieces into the crucible. The iron is now ready for melting. Both the crucible tongs and the crucible grabber thingy I'm using later in the video are DIY projects. You might be able to buy them somewhere, but there are a lot of instructions on the internet and it's quite easy to build them yourself. While the furnace is already white hot in the inside, I'm putting my graphite molds near the opening of the furnace. This heats them up and removes any traces of moisture that are left on the mold. This is very important because molten metals can explode when they come into contact with water. For all my casting operations, I like to use fire bricks as my working surface. The stones are designed to survive large temperature differences. They are also what my furnace is made out of. Never set your hot crucible onto concrete. There's always water trapped in the concrete and the concrete might explode. A small piece of iron fell out of the crucible. It seems that it is already liquid. The air of the burner is now blowing directly onto the liquid iron. This causes sparks to fly out of a crack in the furnace wall. I think the sparks are a great show. And these are also the same sparks that you can see on the sparkler. The inside of the furnace is now so hot that neither the camera nor I can see anything. That's why I filmed the next clip through my welding goggles. The iron was very close to the melting point. About 10 minutes later, everything was completely liquid. The molten iron is now ready for casting. Despite the extreme heat, casting the cast iron was a very pleasant experience. The molten iron has a very low viscosity, a lot lower than copper or aluminium. It fills the mold perfectly. Before casting the iron, I have removed most of the slag with a spoon. I'm still surprised that the spoon didn't melt immediately. When casting iron, it's very important to remove the slag from the crucible, because the iron slag is very corrosive to the material. A year ago I would have never thought that I might be able to melt cast iron in my garden, but today everything went really well. Casting metals is a great hobby. I hope you liked this video. If you want to see more casting and chemistry experiments, please subscribe to my channel. See you next time.